Welcome to a lesson with Dr. Powell. Now, let's take a look at how we can compute curvature using this nice formula that we came up with, r prime cross r double prime, all over r prime, the length of r prime cubed. Okay, or we could think of this as v cross a all over v, the length of v cubed. That's what curvature is, and that's the length. So this is a very nice formula that we can use to find our curvature. So let's go for it and see what we can do. All right, so let's suppose that we have this as our position vector, as our position. Maybe we have cosine t, sine t, and maybe we have like 2t. Okay, let's just go with this and see what we can do. So first, let's find the velocity vector, which is negative sine t, cosine t, comma 2. All right, now let's find acceleration. This would be negative cosine t, negative sine t, 0. All right, now we can go for it. Let's cross v and a together. In fact, we can do it right here. Thinking of what goes in this component, we can just look at this part over here, do that minus that. So that's just 0, and then minus a negative, so positive, just 2 sine t would go right here in the cross product. Next, for the middle guy, we have this minus that, but then we changed the sign. That's just 0, and then minus that would be a minus minus, so it'd be a positive 2 cosine t, but then we changed the sign, so it's negative again, so negative 2 cosine t. And then to get this component, we look over here, we get sine squared minus a negative cosine squared. So it looks like we just get sine squared plus cosine squared, which is just 1. Very nice. Squared. And then, yeah. Okay, so that's the cross product. So basically, we need to find the length of this, which we can do right here, the square root of 4 sine squared t plus 4 cosine squared t, and then plus 1. And we can factor out the 4 here and get sine squared plus cosine squared, which is 1. So this is just 4 right here, 4 plus 1, so square root of 5. All right, so this top part is just going to be, let's just put this here, it's just going to be square root of 5. Then we need to find the length of the velocity vector right here, and then cube it. So the length there would be, well, we take this sine squared plus cosine squared plus 4. Sine squared plus cosine squared is just 1. And then we have 1 plus 4, which would be 5, right? And so we have square root of 5 quantity cubed. And so we end up getting square root of 5 all over. Now, square root of 5 quantity cubed is square root of 5 squared times square root of 5. And square root of 5 squared is just 5. So we end up getting this. Those guys cancel, and we end up getting 1 over 5. And so 1 over 5 is the curvature of this helix right here described by that particular formula. Thanks for watching.